I don't have enough space to write my entire title. I want to write everything there. Just like fundamental set of solutions, reduction of order, linear with fixed coefficients, homogeneous, Vronsky, linear dependence, independence, all of that I wanted to put in the title. Man, it just gave me space for 5 words. All right, is everybody good there? Hello, Macy.
Hello.
Good, how are we doing?
I'm good. How are you?
Wonderful, wonderful. Thomas, I see he's not, is he here? Hello, Mr.
Yeah, I'm here. I just wasn't at my mic at the second when you said something.
No, I just have the bad habit to sometimes just call people to say hi.
Okay. Hi. Hey.
All right, man.
How are you?
I'm good. Just that my face is that it titled today, differential equations. So
yeah.
I'm like the voice from somewhere else, from the other world. Ethan, are we here?
Hey, how are you?
I'm good, and I hope you are too. We got William. Mr. William, hello. Cooper.
Oh, yes, sir, I'm here.
Okay.
Hey, how are y'all doing?
We're good. Just making sure everybody is in. So, and it's time, and we're just gonna have to start somehow. Do you guys have any specific questions before I start doing what I do?
I may need a minute to find my homework.
No problem. Because there are two things. I either answer your questions or I go ahead and I answer my own question. It's no difference to me. So first of all, the first thing I'm going to do is to remind you that on that test, the first topic, which wasn't on your homework, is going to be Bernoulli equations. So that's the first question that you have. And I'm gonna give the question. Now we solve the following Bernoulli equation, and it's going to be given to you as x y prime, sorry, plus y equals, and let me actually here have not plus y but minus y, okay? Xy prime minus y equals x squared y squared. So that's the problem, and that's what we call the Bernoulli equation. And how do we solve the Bernoulli equation? Step one would be you get rid of that guy we have there, divide the whole equation by y squared. So we are going to have x y prime y to negative 2 minus y to power minus 1, which is y divided by y squared, equals x squared. So that's your first step. Divide by y to the power n. In your next step, you're gonna substitute w equals what you got here, and that is y to the power minus 1, which is 1 over y. And then you gotta find dw over dx, which is derivative of this. The derivative of 1 over y is minus 1 over y squared times derivative of y, which is dy over dx. And you are going to solve this for 1 over y squared dy over dx, and you're going to get, in this case, when you solve, you just send the minus 1 to the other side. It becomes minus dw over dx. And this is what you have right there in that equation. So you replace that quantity by negative dw over dx. So that's the third step. So that's going to be x and then negative dw over dx minus, and this is w, equals x squared. Now, when you do this, you get this equation. It's always going to be a linear equation. So we solve it as a linear equation, which is why on the next step, what you do is you standardize and the way you standardize a linear equation is that you get rid of the coefficient that you have in front of the derivative. So you make that coefficient 1. Here it's negative x. So we multiply the whole thing by 1 over negative x. And so that becomes dw over dx plus 1 over x w equals minus x. So that's what you will get in the standard form. After the standard form, what you need to do is find the integrating factor. So the integrating factor, that's mu of x equals e to the integral of p of x dx, and p of x is what you have in front of w, and that's 1 over x. So that's e to the integral of dx over x, which is e to the ln of x. And we don't take the constant because we just need one function. So e to the ln of x is x. So our integrating factor is x. So we get to the next step, which is multiply the equation by the integrating factor and combine the left and so when you do so, the integrating factor being x, you multiply this whole equation by x. So you get x dw over dx plus w equals negative x squared. And this combines into d over dx of the integrating factor x times w equals negative x squared. And from there, you get to the next step, which says integrate both sides. The integral of the derivative here is just the function xw equals integral of negative x squared dx, and that's negative 1/3 x cubed plus a constant. Never forget the constant of integration. And then you got the last step, solve. W is 1 over y in this case, and that is minus 1/3 dividing by x squared plus c over x. You can solve for y, get y equals 1 over minus 1/3 x squared, c over x, which could be same as x over c minus x cubed over 3. Any questions? Is there any questions? All right, so what are the questions that you were looking for? Now the second question, so that will be question 2, second type of question, second topic. That was on fundamental set of solutions. And linear dependence. So you have something on that topic. And one question could be, are the functions x natural log of x squared natural log of x linearly independent? So if you ask if these functions are linearly independent, then what you need to do is to compute the Wronskian and show that that Wronskian is not equal to 0. So W is, you got x natural log of x squared natural log of x. The derivative of x is 1. The derivative of this is natural log of x plus 1. The derivative of that is 2x natural log of x plus x. Then you get the second derivative. Derivative of 1 is 0. Derivative of this is 1 over x. And derivative here is 2 natural log of x plus 2. And the derivative of x is 1. And then you can compute the Wronskian. I can split using the first column. So that's going to be x. And then minus 1 to the power 1 plus 1, that is 1 times x times what is remaining when I remove this row and this column. That's natural log of x plus 1, 2x natural log of x plus x, 0, 1 over x, and 2 natural log of x plus 3. Then I take the second one, negative 1 to the power 1 plus 2. That is negative 1 to the power 3, that's minus 1 times 1 times what I get when I remove this column and that row, that's x natural log of x x squared natural log of x, and 2, 1 over x. And 2 ln of x plus 3. That's it. And we go ahead and we compute this. If we want this is x, and then cross multiply here, you get 2 natural log squared of x plus 3 natural log of x plus 2 natural log of x. That's plus 5 natural log of x plus 3 minus 1 over x to multiply by that. You get minus 2 natural log of x minus 1. That's the determinant that is inside, and then you get a minus, and you compute this guy. That is x, 2x natural log square of x plus 3x natural log of x minus x natural log of x for that. And then you make sure that you do the right algebra in between. This is 2x natural log of x squared minus 2x natural log of x squared. So these two cancel. Now here you have 3x natural log of x minus x natural log of x. So that's 2. And then that's a minus. And here you have 5 natural log of x minus 2, that's 3. So that's 3x natural log of x you have here. 3x natural log of x, because these become 3. 5 minus 2 is 3. So 3x natural log of x minus 2x natural log of x from these two. So that is just x natural log of x. And so you have these taken care of. And you remain with 3 minus 1. That is 2. So 2x. That's it. And so you got that w. And this is definitely not the function 0. Therefore, x natural log of x squared natural log of x are linearly independent. Questions? Are you guys in here?
I'm here.
Yes.
Okay. It's so calm that I'm thinking that I'm somewhere alone, maybe in the desert, because I don't even hear anybody breathe. All right, and so this question could have two parts. You could be asked if you have linearly independent functions, and then separately, I might ask you, are the following functions, do the following functions form a fundamental set of solutions of a given equation? So let's say we have the equation this, and I say y1 is e to the x, y2 is x e to the x, and I ask, do the functions y1 and y2 form a fundamental set of solutions, of the given equations. So do the two functions form a fundamental set of solution of the given equation? So nowhere in this question you are asked to solve the equation. The question is, do the two form a fundamental set of solutions? And nobody cares at this point that you might know another way of solving this equation. It is not required. What you're being tested on is whether you know or not when a set of functions forms a fundamental set of solutions. And you are given a simple equation because the matter is not about seeing how you can solve difficult problems, but to apply that on this simple problem. So don't rush ahead and start showing me the lambda squared minus 2 lambda and so on here, because that has nothing to do with this question. So for this question, what you do clearly is, as we said, notice that this is a second order equation. Second order equation. And two functions. It's important because if you have a second order equation, you have three functions, there's no way they are going to form a fundamental set of solutions. If you have a third order equation and you have two functions, there is no way they are going to form a fundamental set of solutions. So it is important to make sure you mention that the order of the equation matches the number of solutions that you got. So second thing, you need to show that each of the functions is a solution. In this case, because y1 is e to the x, y1 prime is e to the x, y1 second derivative is e to the x. So you get e to the x minus 2 e to the x plus e to the x, and that is 0. So yes, that's a solution. If you take y2, that's x e to the x. y2 prime is x e to the x plus e to the x. And y2 second derivative is x e to the x plus 2 e to the x. And then you plug them in. X e to the x plus 2 e to the x minus 2 x e to the x plus x e to the x equal. You get x e to the x minus 2x e to the x plus x e to the x. I'm missing something here, so that this is plus e to the x. And then you have 2e to the x minus 2e to the x, and that's 0 as well. So this is the second derivative, that's the derivative, and that's the function itself. So y2, y2, y2. And you can see that you have shown that this thing is also 0. So both functions are solutions. The two functions are solutions. So that part is done. And now you get the third part. You need to show that the functions are linearly independent. And to show that the functions are linearly independent, well, you find the Wronskian W, that's e to the x e to the x, derivative e to the x e to the x plus e to the x. So that's x e to the 2x plus e to the 2x minus x e to the 2x, and that is e to the 2x. And e to the 2x is definitely not the function 0, therefore y1 and y2 are linearly independent. And the combination of these three facts, 1, 2, and 3, is what makes y1, y2 a fundamental set of solutions. So e to the x e to the x forms a fundamental set of solutions. That's it. Questions? So that's the third question of that test, how it will be labeled. Then you have question number 4, reduction of order. And I ask you to please read or watch and follow the steps, because what I'm grading is how you follow these steps to learn how to do this procedure, not just find the final answer for me. I'm not interested in the final answer. I'm interested in the method that you're using. If you choose to use any other method, prove it and use it. Now here, the question could be find the general solution. So the question could be find the general solution or find a second solution. So any of the two. And here, for example, I could give just an easy problem like the one we had before. It's a y double prime minus 2y prime plus y equals 0. y1 of x equals e to the x, for example. And so what are the steps? That's the most important thing, the steps. Okay. You get here, right here, that's p of x. And you have w of x equals c e to the integral of p of x dx with a negative sign, c e to the negative integral of p of x dx. And here that's c e to the negative integral of minus 2 dx. That's c e to the 2x. And then for y equals u y1 of x, you got u prime of x equals w over y1 squared. We proved this, so you can use it. And your w, you just computed it. That's c e to the 2x over, and y1 is given, that's e to the x squared. And some of you sometimes have problems with the powers. This is e to the x squared. It's e to the x that is squared. It's not x that is squared. When e to the x is squared, Then x is multiplied by 2. So that's e to the 2x. And they get canceled. So we get that u prime is equal to c. Then you find u of x as integral of u prime of x dx, u prime being what you found. So that's integral of c dx. And that's cx plus the new constant of integration c1. And the next step is you get y. That's u of x, y1, which is cx plus c1 times e to the x. Cx e to the x plus c1 e to the x. So if I'm asked to find a general solution, this is the general solution. If I am asked to find a second solution, y2 is x e to the x will be a second solution. If asked. That's the other solution that is there, x e to the x, which is different from the first one that you had. Now notice that in this class, there is already a topic that shows you how to solve this equation, but that's not what the question is about. The question says, find a general solution using reduction of order. So I'm interested in the question in seeing how you use reduction of order. And if the question is simplified like that, is just to make sure you don't waste too much time trying to compute some integrals that might be hard to do. I give you a simple question. So focus on the question, reduction of order. So you do reduction of order, even if you know something else about the question, about the equation. Any questions? All right, the next question is number 5, second order linear homogeneous equation with fixed coefficients. Now you could have several questions here because we do assume that they are the easiest you can have for this test. All you need to do is write down the Euler equation, solve it, and plug into the formula for the solutions. So let's say I give back that same question that we have solved already 3 times. And the question is just solve this. Right. Y of 0 equals 0. Y prime of 0 equals 1. So we have a problem like that. Answer, it's second order linear fixed coefficients. So you get lambda squared minus 2 lambda plus 1 equals 0 that you solve. You get lambda 1, 2 equals, I use the quadratic formula, so that's minus 2b plus minus square root of 2 square minus 2 squared, it's 4 minus 4 times 1 times 1, 1 here and 1 there, divided by 2a, and that is equal to 2 plus minus 0 over 2. So that's 1 and 1. So we have a double root. And when we have a double root, y of x is c1 e to the lambda, which is here 1, plus c2x e to the lambda x, and lambda is 1. That's it. And then y of 0 is 0. That would mean c1 equals 0 when you plug in 0, because that's c1 plus 0. And then if we find y prime of x here, before plugging in the, get c1 e to the x plus c2 e to the x plus c2x e to the x. So y prime of 0 equal 1, that will give us y prime of 0, that is c1 plus c2 equal 1. So you get c2 equal 1. And therefore, your answer is y of x equals x e to the x. And so that is the only solution of that equation that satisfies the initial conditions. Questions? Any questions? We have such an equation, and that's all on the second order linear with fixed coefficients, homogeneous. So again, here you would have lambda squared minus 2 lambda plus 2 equals 0. So, and I use the quadratic formula again, lambda 1, 2, minus 2 is 2, plus minus square root of minus 2 squared, that's 4, minus 4 times 2 times the 1 that we have here, over 2 times 1, which we have here. So that is 2 plus minus square root of 4 minus 8, that's negative 4 over 2. And because of the negative 4 that you have under the square root, you have I that shows up. So that's equal to 2 plus minus 2I over 2. So that's 1 plus minus I. So here you got complex conjugate roots. This number here is alpha, and the coefficient here, which is beta, is 1. And your answer is written as y of x equals c1 e to the alpha x cosine beta x plus c2 e to the alpha x sine of beta x. And in this case, that's c1 e to the x cosine x, because alpha is 1, beta is 1, plus c2 e to the x sine x. That's it. Third problem could be so we could have this function, this equation. So also linear second order fixed coefficients. So in this case, you would say, okay, lambda squared minus 2 lambda minus 3 equals 0. And lambda 1, 2, that's minus minus 2, 2 plus minus square root of minus 2 squared 4 minus 4 times. And here, be careful, that's minus 3 times 1 over 2 times 1 that is there. And now you can see that's minus and minus. That becomes plus. Most of the time, that's what people miss. That's minus and minus plus. 4 times 3, 12, plus 4, 16. Square root of 16, 4. So 2 plus minus 4 over 2. And when you simplify that, you get 2 plus 4 is 6 over 2, 3. 2 minus 4 is minus 2 over 2 minus 1. That's it. And then you can see we got two roots that are real and are different. Therefore, your solution is y of x equals c1 e to the 3x plus c2 e to the minus x. And that's it for second order equations with fixed coefficients. Questions? At the beginning, someone said he was looking for the book for questions.
Are we always normally going to do quadratic equation for these problems?
What?
Are we always going to use quadratic equation for these problems?
If it's second order, then you use the quadratic.
Okay.
We are solving second order. That's where you use the quadratic. More than 2, you cannot use the quadratic formula. Now, that was 5. And 6 is higher order. Linear ODE with fixed coefficients. Of course, homogeneous. Let's see, in the first one here, we solve this. Fourth derivative plus twice second derivative plus the function equals 0. If you have such an equation, what do you do? Now I'm waiting for you guys to write down the Euler equation and see how this solves out. Anyone to share something?
I have an answer.
Let's go ahead. Your first step.
So I rewrote it as lambda to the fourth plus 2 lambda squared plus 1 equals 0.
Okay.
And then that factors out to be lambda squared plus 1 squared equals 0,
Yep.
which means lambda 1, 2, 3, and 4 are going to equal plus or minus I. Because it would equal, if you it'd be lambda squared equals -1.
Is lambda 1, 2 is plus minus I. And yeah, repeat it. Right? And that being because this gives you lambda squared plus 1 equals 0, and the repeated because of the square that you have there. And lambda squared plus 1 equals 0 gives you lambda 1, 2 equals plus minus I. That's correct. And so from here, what's the answer that you wrote? Y of x equal?
The answer I got is y of x is equal to c1 e to the 0x cosine x, because the alpha is 0 and the beta is 1,
Yep.
plus c2 e to the 0x sine x, which I guess I don't have to put any of that, but I did and then rewrote it.
Yep, that's fine.
And then plus c3x cosine x
Mhm.
plus c4x sine x.
Yep, because of that twice. That's it. All right. That's how we do. Let's see, I get the other one. Now assume we have this equation. Now it'll take a few minutes to solve.
Is that 2 prime or on the first y?
4, and this is
Okay.
2.
Thank you.
You're welcome, sir. Anyone with proposition? Does John want to try?
I'm still trying to solve it.
Perhaps give me the Euler equation.
Oh yeah, I can do that. Got lambda to the fourth minus 3 lambda to the third plus 2 lambda to the third equals 0.
That's correct. Okay, anyone to tell me what's the next step on this?
You can factor out lambda squared.
That's correct. So now after factoring out lambda squared, it becomes easy. Because right there you can clearly see that you get lambda squared equals 0, which gives you lambda 1, 2 equals 0. You got two answers, 0. And then the other one gives you lambda squared minus 3 lambda plus 2 equals 0. And on that you can do the quadratic formula because it's squared. So you got lambda 3, 4 equals minus 3, that's 3, plus minus square root of minus 3 squared, 9, minus 4 times 2 times 1 over 2 times 1 from 1 from here and the 2. And now you got 4 times 2, 8, 9 minus 8, 1, square root of 1 is 1. So 3 plus minus 1, it's 4 and 2. So divided by 2, that's 2 and 1. So the two answers remaining are 2 and 1. So you got the 4 answers, 2 zeros, and then 2 and 1. And now you can write down the final answer. How do we get the final answer here? I need help.
For the first two, don't use the multiplicative rule, so it'll be C1 e to the 0x, so just C1 plus C2x e to 0x, which is just 1.
Mhm.
And then C3 e to the x, and then plus C4 e to the 2x, because 1 and 2 are the solutions to the other quadratic.
That's right. So you get C1 plus C2x plus C3 e to the x plus C4 e to the 2x. And that's it. That's the final answer. And you go free, no questions asked, 100%, and everybody is happy. Any questions? Any other questions that you want to ask me on the material?
Can you explain where you did, I guess where lambda squared equals 0? Did you just solve for that, or how did you do that?
So for that, lambda squared equals 0, I get lambda equals 0 twice because the power is 2.
Okay.
Same as what we did on top here, lambda squared plus 1 squared. I solve lambda squared plus 1 is 0. That's it, plus minus I, and it's twice because of the square.
Thank you.
If that wasn't lambda squared, if it was lambda plus 1 squared, then I will solve and get minus 1. Now, one more thing. Let's see here, I got the third derivative minus second derivative plus the first derivative minus the function equals 0. Have something to say, Devin?
I have an answer.
Right, let's go step by step.
Okay, so the first step would be to replace the y's with lambda, so you get lambda cubed minus lambda squared plus lambda minus 1 equals 0.
Correct. And then,
The second step, you can factor, which I factored by grouping. So I grouped the lambda cubed minus lambda squared together and the lambda minus 1 together. And you can factor lambda squared out of the first one and a 1 out of the second one. So the factor gives you a lambda squared minus 1 or plus 1 and then times lambda minus 1 equals 0.
right.
And so that gives you 3 answers. Lambda 1 is 1, and then lambda 2 and 3 is the square root of negative 1, which is just plus or minus I.
Mhm. Correct.
And then for the answer, just y of x is equal to c1 e to the x, and
Mhm.
then c2 e to the 0x cosine x plus c3 e to the 0x sine negative x.
Yeah, but it's all good to always keep it as sine x, because putting the negative in there is not going to change anything. Okay. Good. Perfect. Now that's it. That's the solution. Any questions? Thank you. Now let me give you a last question before we go on reduction of order. So find a general solution. Anyone with good ideas? Want to try, Michael?
No, I'm barely staying awake right now. I didn't get much sleep, so I'm gonna have to rewatch this entire session on YouTube later.
Okay. Preston? Can you help with this?
Did you say Preston?
Yes, sir.
Okay, give me 1 second.
Yep, we have only 5 minutes left.
Okay, so first you need to divide by x squared.
No, this is reduction. In the reduction of order, you got to start by Differential. Oh, you mean, I get that. Yeah, I get the x squared that you think you're talking about. You're right. I was wrong. Sorry. So you divide that by x squared. You are perfectly right. So that is y double prime minus 3 over x y prime plus 4 over x squared y equals 0. Thank you. Then
You want to find your Wronskian, which is going to be c e to the negative integral of p of x, which is negative 3 over x.
So that's c each. When you log that in, you get 3 natural log of x. What is this equal to?
That's going to be equal to c x cubed.
The x cubed, right? Because we take this 3 inside, it comes inside as x cubed, and then e to the natural log, just let x cubed there. Then what's next?
Next, you need to find
You got y equals u.
u prime x.
And so u prime is w over y1.
y1 squared.
Right. Let's see, x cubed over, and y1 is x squared, and you square that, so that's x squared squared. So that's, is that correct?
Yeah. You then need to integrate both sides.
And what do we get here? X squared squared. I'm actually thinking, asking myself
It
if
should be c over x, right?
there's no mistake anyway. Yeah.
So you're going to get c natural log x plus c1.
That'll be c over x, right?
Right.
Good. And from that, you're gonna get y1 u of x equals integral of c over x dx. I'm having a bad feeling about this answer. I don't know why. And so here, what happens? So when we integrate here, what do we get?
You're gonna get C natural log x.
Natural log of x plus the constant of differential, right? That's it. And then you take that to multiply by y1 to get y of x equals c natural log of x plus c1 times x squared. But it's fine. I was thinking too much. It's just that it's a case of double solution here, and so that natural log is going to come out. So that's it. That's the general solution of that problem. Any questions? Thank you very much, dear. Any questions? That's it. If there's no question, I'll be happy to say see you on Thursday on the test. Review thoroughly, watch the videos if you were not in class. And if you were not in class, then probably don't hear me, right? So please review the notes and make sure that you are able to use to solve any of the topics that we have covered today, because that is exactly what is going to be on your test. You will not be surprised unless you want to be surprised. See you next time.
Thank you.
Thank you.
Have a great day.
Thank you.
Thank you.
You're welcome.